Hello everyone and welcome to another video in this series about the basics of C# programming with Unity. Today we are going to talk about comparison operators, which allow you to compare values with each other, and logical operators, which allow you to perform logical operations on Boolean. The results of these operations can then be used to make decisions in your code. Let's start with the comparison operators. Here are the main operators you'll be using. The double equal to check that two values are equal, the exclamation mark equal to check that two values are not equal, the less than sign to check that one value is strictly less than another, the greater than sign to check that one value is strictly greater than another, and finally, less than or equal to and greater than or equal to check that one value is less than or equal to or greater than or equal to another value. The values to be compared are placed on either side of the operator. The result of a comparison is always a Boolean, so either true or false. For example, we can declare two variables of type int with values 5 and 10. Then, let's make a few comparisons. We perform an equality test, so we compare A and B to find out whether the values contained in A and B are equal. The result of this comparison will be either true if the values contained in A and B are equal, or false if the values are different. The next test checks whether the values are different. The result of this comparison will be either true if the values contained in A and B are different, or false if the values are equal. We can then test whether A is strictly less than B. We can do the same to test whether A is strictly greater than B. Finally, we can test whether A is less than or equal to B and whether A is greater than or equal to B. Sometimes, in the float, you can have the value NaN for not a number, something that does not represent a number. This happens when the result of a calculation cannot be defined, such as 0 divided by 0, or another calculation involving a number that itself has the value, not a number. The equality operator, less than, less than or equal to, and greater than or equal to compare a value to not a number, always return false. The inequality comparison with the exclamation mark equal between two not a number also returns true, as two not a number will be different. To find out if a float is not a number, it's best to use the float.isNotAnumber method with the float you want to test between parentheses. Let's test it in Unity. Create a script and call it comparison operators. Open it in Visual Studio. In the start method, use these operators to compare values and display the results in the console. We declare an int, call it A, and give it the value 5. We'll declare another int, call it B, and give it the value 10. We are now going to test whether A is equal to B and store the result in a Boolean variable. Let's do the same thing to test inequality. If A is strictly less than B, if A is strictly greater than B, if A is less than or equal to B, and finally, if A is greater than or equal to B. We then use debug.log to display the results in the console. Let's go back into Unity to test. If you still have the game object from the previous episode, you can delete or deactivate it. Create a new game object and add our script to it using drag and drop. Then click play. The console shows the result of our comparisons. A is not equal to B, A is different from B, A is less than B, A is not greater than B, A is less than or equal to B, and finally, A is not greater than or equal to B. Now let's do a test with not a number. I declare a float C, whose value is 0 divided by 0. It will therefore have the value not a number. Let's compare it with A. Display the results in the console using debug.log. Note that not a number is neither equal to, less than, nor greater than A. On the other hand, it is different from A. Let's move on to logical operators. Logical operators allow you to perform logical operations on booleans. The main logical operators you will come across are the following: the negation operator, represented by an exclamation mark, the logical AND, represented by an ampersand, the logical OR, represented by a vertical bar, the exclusive OR, represented by a circumflex, as well as the conditional logical AND, represented by two ampersands, and the conditional logical OR, represented by two vertical bars. The negation operator is placed in front of a boolean to obtain the inverse of the boolean's value. If the boolean is true, then the value obtained will be false, and on the contrary, if the boolean is false, then the value obtained will be true. For example, if we declare a boolean A and initialize it with the value true, then if we declare a boolean B with the value not A, we will get the value false in our variable B. The AND is placed between two booleans. The result of this operation will be true only if both booleans are true. If one of them is false, then the result will be false. For example, we can declare two booleans A and B, with values true and false. If we declare a boolean C and assign it the result of the AND between A and B, the boolean C will have the value false because the two booleans do not have the value true. The OR is also placed between two booleans. The result of this operation will be true if at least one of the two booleans is true. If both are false, then the result will be false. For example, we can declare two booleans, A and B, with values true and false. If we declare a boolean C and assign it the result of the OR between A and B, the boolean C will have the value true because at least one of the two booleans has the value true. The exclusive OR is placed between two booleans. The result of this operation will be true if only one of the two booleans is true and the other is false. If both booleans are false, or if both booleans are true, then the result will be false. For example, we can declare two booleans A and B with values true and false. If we declare a boolean C and assign it the result of the exclusive OR between A and B, boolean C will have the value true because only one of the two booleans has the value true. Concerning conditional logical AND, this gives the same result as AND, but allows the second term not to be evaluated if the first is false. Because if the first term is false, then the result of the AND will necessarily be false. So it is not necessary to evaluate the second term to determine the results. This allows you, for example, not to execute the rest of the instruction if the first condition is false. And for the conditional logical OR, it's the same as the OR, but once again means that you don't need to evaluate the second term if the first term is true. Because if the first term is true, the result of the OR is necessarily true. This means that the rest of the instruction is not executed if the first term is true. You can also use compound assignments with the logical operators AND, OR, and exclusive OR. As a reminder, compound assignments allow you to perform an operation on a value stored in a variable and store the result of the operation in the same variable. So here we have an example where we declare a boolean test, which we initialize with the value true. And then we make compound assignments. In other words, we'll AND the value already contained in test and store the result in test. You can do the same thing with OR equal and exclusive OR equal. As with arithmetic operators, logical operators also have an order of priority. The negation operator is evaluated first, then the AND operator, followed by the exclusive OR, and the OR. Then come the conditional logical operators, with the conditional logical AND taking precedence over the conditional logical OR. If you also take into account the comparison operators and arithmetic operators, here is the order of priority from highest to lowest. First, you have the negation operator, then the arithmetic operators in their own order of priority, then the comparison operators, and finally the logical operators in their own order of priority. As with the arithmetic operators, you can change the order using parentheses. Now let's go in Unity to test this out. Create a script called comparison and logical operators and open it in Visual Studio. In the start method, we'll declare our first variable of type int, named ammo, and give it the value 11. Declare a second variable of type bool, named isFriendlyTarget, and give it the value false. We can now declare a third variable of type bool named catShoot and give it the value ammo strictly greater than 0, conditional and, negation operator, is friendly target. In this way, in this third variable catShoot, we should have the result true if the number of munition is strictly greater than 0 and if the current target is not friendly. We've used the conditional logical AND operator here, which means that the two terms must be true for the result to be true. And if the first term is false, then we don't even check the second term. The first term is the result of a comparison. Do we have any ammunition? And the second term is a boolean that we've inverted with the exclamation mark. If the target is friendly, then this term will be false. And so, even if we have ammunition, we won't be able to fire. Let's take another example. We'll declare boolean, jump key was pressed, and give it the value true. Declare a second boolean, is double jump allowed, and give it the value true. Finally, we create an isGrounded method, which returns a boolean. In the body of the method, we'll do a debug.log to display a message in the console saying that we are checking whether we are on the ground, and then we'll return the value true. Now that we have these elements, we declare a boolean have to jump and give it the value of the result of the operation jump key was pressed, conditional logical AND, we open a parenthesis, is double jump allowed, conditional logical OR, and the call to the isGround method. Close the parenthesis and add a semicolon. In this boolean, the value should be true if you want to jump, false if you don't. You want to jump if you have pressed the jump key, and if you are on the ground or if double jump is authorized. The parentheses here are used to group the OR between is double jump allowed and is grounded. Without the parentheses, the boolean will be true as long as you are on the ground, even if jump key was pressed as the value false. We also used conditional logical operators. For example, if jump key was pressed as the value false, then we don't evaluate what follows, because the result of the AND will inevitably be false. So we don't have to call the isGrounded method. Similarly, if jump key was pressed as the value true, then we evaluate is double jump allowed. And if this boolean has the value true, then we don't evaluate the rest since the result of the OR will necessarily be true. Once again, we avoid calling the isGrounded method. If this method is costly in terms of resources, this means that it can only be called if really necessary. If we write the same operation but in a different order, for example, we start by calling the isGrounded method or is double jump allowed, and finally the AND jump key was pressed. We'll get the same result, but this time the isGrounded method is necessarily called because it's in the first position, and it's a waste to call a method which is potentially costly in terms of resources when you may not have pressed the jump key. Be careful when testing the equality between two floating point numbers. Because of the limited precision of floating point numbers, comparing two floats directly with double equals can sometimes give unexpected results. Let's do a test. For example, declare a variable a containing the value 0.1, then a variable b containing the value 10. Then multiply these two variables and store the result in a variable c. We should normally have the value 1 in this variable since 0.1 multiplied by 10 gives 1. We now store the value 1 in a variable d, and test the equality between c and d. Display this boolean in the console. It is possible that these two numbers are not equal. We can use a method called matf.approximately to compare two floats. This method will compare whether the two floats are similar, so with a value that is very close to each other. Let's run a test with this method and display the result in the console. We can see that this time the comparison returns true. But sometimes matf.approximately isn't enough. The gap is too wide. Let's take this example. I declare our first float e and give it the value 10.123 minus 10. So we should have 0.123 in the variable e. I then declare a variable f with the value 0.123. And finally, I do a matf.approximately between e and f and display it in the console. Note that even matf.approximately no longer considers these two floats to be equal, as the difference between them is too large. You can display their values in the console using debug.log. And indeed, there is a small difference. In this case, we can test it ourselves by setting the larger difference. To do this, we are going to create a method. Let's go back to Visual Studio. So, we are going to create a new method that returns a Boolean type. We'll call it isApproximatelyEqual, and it will take as parameters a first float, a second float, and finally an optional parameter allowing us to specify the maximum difference we need to have between the two floats to consider them to be equal. I'll give it the default value of 0.00001. After the return keyword, we'll do a little calculation, checking whether a is greater than b minus the difference, and whether a is less than b plus the difference. This will allow us to see if a and b are close enough. Let's call this method instead of mathf.approximately and return to Unity to test. You can see that all floats are now considered to be equal. And that's it for this video on comparison operators and logical operators in C#. I hope you found it useful. In the next video, we'll talk about conditions and how to use them to make decisions in our code. If you have any questions, don't hesitate to ask them in the comments. Thanks for watching and see you next time.